Are there certain bacterial strains that help us produce more serotonin in the gut?
Yeah, there are. The problem is that one of the sad things we've learned about Roundup and glyphosate is that glyphosate was actually developed as an antibiotic. It was patented as an antibiotic by Monsanto. It wasn't patented as a weed killer. So it works on the shikimate pathway, and bacteria actually use the shikimate pathway to reproduce. We don't, and so Monsanto convinced the FDA, hey, it's perfectly fine. You can swallow a gallon of glyphosate and you'll be fine. What we didn't know is that glyphosate particularly targets the tryptophan pathway bacteria that make serotonin. So people who are exposed to glyphosate, they're the good guys that make tryptophan, that make serotonin, have been wiped out. And it's no wonder that we have an epidemic of depression and anxiety. Now, granted, we can blame cell phones and COVID and all that, and that has a place. But to target the actual bacteria that are responsible for making serotonin.
Dr. Gundry, it's a huge honor to have you on the Extend podcast today. Thank you for making the trip to see me.
Well, thanks for letting me come. It's great to be here.
I know. The last time I was with you in person, you did a talk on stage.
Yeah.
And you blew everyone away. And you were just then writing this book, I think, as well, right?
Yes,
The
that's
Gut-Brain
right.
Paradox.
That's right.
And even with just some of the little nuggets that you gave us on that stage, I could tell like this book was going to be a big deal. And here it is. It's finally out, The Gut-Brain Paradox.
Yeah, it's, we were talking off camera, but most of my books, and this is number 10 in the series.
Wow.
I'm trying to keep up with Mark Hyman.
Yeah.
It kind of builds on the previous book.
Right.
And in the previous book, which was Gut Check, I really started to delve into how the gut microbiome really is not the second brain as we've been taught over the last few years, but that it's actually the first brain that is actually telling the second brain what it wants the second brain to do. And that kind of bothers most people because how in the world could a single cell organism have that much effect over this massive, important cathedral of learning and thinking, which is our brain?
Right.
And yet, the more we've learned about the gut microbiome, the more nuance we're able to realize how this is a symbiotic relationship. And just for instance, the Human Microbiome Project wasn't finished until 2017. And the word microbiome actually was coined in 2002.
Oh, really?
It's that new a term.
Yes.
And so the Plant Paradox, my big monster book, was published in 2017, actually before the Human Microbiome Project was finished.
Got it.
And literally with every, I can exaggerate, with every passing day, thanks to how we can now understand who these guys are and what they do, we learn more and more nuanced of how the communication system between the microbiome and, for instance, their sisters, the mitochondria, and the brain, and for that matter, any other organ in our body. And that's what's really exciting, is that rather than being threatening, we ought to realize that if we take care of our gut microbiome, give them what they want to eat, they will actually take care of us. Now, the bad news is that if we give the bad guys what they want to eat, they'll actually hijack our brain and direct us to give them more of the things that they want to eat and keep us from eating the things that the good guys need. And so it's it's a real balance of power. That's
Yeah.
the good news is you can manipulate it.
Yeah. I kind of envision this almost like a battle or a war going on for the communication satellite dish, if you will, between the gut to the brain. And the more bad guys there are, the more they're going to be communicating to our brain what they want versus the good guys. And so we just gotta make sure we're listening to these communications and understanding what they're telling us.
Yeah, it's for a while we thought, well, this is really a tropical rainforest in our gut, and there's up to 10,000 different species of bacteria, fungi, yeast, and viruses that all make this a very complex ecosystem. And this book starts with understanding that a complex ecosystem, the more diverse the species, the more they're all interdependent on each other, the more stable the ecosystem is, the better the tropical rainforest.
Yeah.
And even bad guys in this ecosystem serve a purpose. It's the balance between the bad guys and the good guys that you have to achieve. So I like to use the example of wolves in Yellowstone Park.
Okay.
People may remember that a few years ago, wolves were hunted in Yellowstone Park, and there were bounties on wolves because they were evil. They were an apex predator, and they're evil.
Yeah.
And we ought to get rid of the wolves. And so they literally were destroyed.
I remember this.
Remember that?
Yeah.
So what happened? Well, without an apex predator in Yellowstone, the elk population, which was controlled by wolves, overgrew. And the consequences of that was they actually ended up eating all the saplings.
Right.
The beavers, which would use saplings to make dams, didn't have anything to make dams. The beavers disappeared. The fish population changed. And the whole ecosystem actually fell apart.
I remember this.
Remember that?
And rivers started running in different directions.
Exactly.
I heard, right?
Yeah, because
like the geography changed because
everything
of this.
changed because of this.
Yeah.
And so, luckily, they reintroduced wolves into Yellowstone Park. And I think one of the important things to learn from that experience is it took a number of years for that balance to reestablish.
Right.
And one of the things I've learned, I've been doing this now for 30 years, and I was naive when I first started, when we talked about leaky gut, which was fantasy back 30 years ago. It was pseudoscience.
Right.
And I really thought that we could fix leaky gut in a couple of weeks. And boy, was I naive. The whole problem is we've got to restore this ecosystem.
Right.
And as any of us here in California know, when we have a forest fire and burn everything to the ground, sure, we could plant a bunch of little seedlings, but we'd have to wait 20, 30 years for that forest ecosystem to reestablish. And what I've learned, thankfully through my patients, is that you could swallow all the probiotics in the world, but unless you give those probiotics what they want to eat, which are prebiotics, and unless you actually give them information in short-chain fatty acids like butyrate, like acetate, in fermented foods, they're not going to form this incredible rainforest, and it's going to take a while.
Yeah. So it's not just about the probiotics, not just about delivering the bacteria there. You can deliver them, but they'll just die off immediately if they don't have the information they need to repopulate the forest.
Yeah, that's right. In fact, one of the things that is really fascinating that I wrote about in Gut Check. So there's several keystone species that we're learning about in the gut, and one of those keystone species is a cute little bug called Akkermansia mucinophila, mucus-loving Akkermansia. This bug lives in the mucus layer that coats the wall of our gut. And it actually eats mucus. Now you go, well, wait a minute. Mucus is really important. It protects the wall of our gut from lectins, among other things, one of my favorite subjects.
Yeah.
But you don't want it to be eaten.
Right.
Right? Well, the more mucus it eats, the more the goblet cells in the gut wall make mucus. So it's actually a win to have Akkermansia.
Because it's eating up the old mucus and you're getting new
You're
mucus
stimulating
formed.
it,
You're
yeah.
stimulating mucus production.
But what's really interesting is that Akkermansia is really kind of, it tells the other bacteria that Akkermansia is here and we can party and everything's going to be fine. Now, what was interesting is Akkermansia is very difficult to grow. It took a company called Pendulum Life 20 years to actually grow the human strain of Akkermansia.
Right.
20 years.
I know.
And bless Colleen Cutliffe's heart, she did it. But a competing group out of Israel found that you could take dead Akkermansia, pasteurized Akkermansia, and give it to people, and you would actually have equal benefits and perhaps different benefits from the dead bacteria.
Interesting.
And you go, oh, wait a minute, what's that all about? Well, as I talk about in the book, dead men tell no tales, but dead bacteria do. And because bacteria actually know who's around them, they can see the bacteria next to them. They can count the bacteria next to them. And they read the barcode on the cell wall of the bacteria, just like reading Braille. And you go, oh, that's Akkermansia. And Akkermansia is here. And Akkermansia is a good guy. So I should, relax and, Akkermansia is in the house.
Yeah.
So now we know that probiotics like yogurts don't work by swallowing live bacteria. They work by the fact you're swallowing dead bacteria, but they in turn are able to tell the other bacteria that they're there. So
the dead bacteria can work as well as a live bacteria.
and maybe better.
Really?
Because one of the things we've learned is that if you don't have the right balances in your gut, or let's suppose most of us, unfortunately, our mucus layer is long gone, and for various reasons, we talk about it in the book.
Yeah.
So if you put in live Akkermansia, just as an example,
Sure.
and you don't give it anything else to eat, it will start eating whatever mucus is there. And we've seen actually a number of people actually get worse when they're eating live Akkermansia because it's gobbling up mucus. But the dead Akkermansia doesn't. And so it could actually foster other bacteria for making these short-chain fatty acids.
Interesting. So how can people get dead Akkermansia? Is this a product that you can get?
Yep, there's a number of pasteurized Akkermansia.
Oh, okay.
And it gets, with every passing day, it gets more complex.
Yes, of course.
And I'll give you an example that I talk about in the book. Years ago, I usually present at one of the big microbiome meetings in France. And the organizer of that meeting, who I've known for years now, I'd say 10 years ago, we were talking. And Marvin Aid is his name. Hello, Marvin. And we were talking, and he was saying, the bacteria in our gut talk to our mitochondria because they're sisters, because mitochondria are actually ancient engulfed bacteria. They have their own DNA, which is bacterial DNA. And we get most of our bacteria from our mother through the birth canal. as I told Maria Shriver, your mother took a crap on you. And
So wait, we get it through the birth canal? I thought it was a genetically transferred mitochondrial
no,
DNA.
well, the mitochondrial DNA is
Yes.
female,
Uh-huh.
correct.
Right.
Our microbiome is initially given to us by our mother.
Got it. Right.
So
right.
the microbiome is female
Yes.
initially, and our mitochondria are female.
Yeah, makes sense.
So these are sisters, and these sisters talk to each other.
I see.
So Marvin was saying these guys talk to each other, and I'm going, yeah, right. How are they talking to each other? And he says, well, we don't know yet, but I guarantee you that they're talking to each other. And since that time, the guy was absolutely right. And the levels of conversation are far more than we possibly imagine. 3 books ago, I wrote The Energy Paradox, where these gasotransmitters, like hydrogen gas, like carbon dioxide, like methane, like hydrogen sulfide gases, are actually part of the communication system between the microbiome and us. That was the first level.
Okay.
Then we realized that even short-chain fatty acids like butyrate are a communication system. But the really cool part now that I go into in this book is people are beginning to hear about exosome therapy and extracellular vesicles. So extracellular vesicles are little tiny, I call them text messages, that carry information, whether it's mitochondria, whether it's microRNA, mRNA, whether it's pieces of DNA, from bacteria, and also from plants, by the way, that are non-immunogenic and that actually can tell DNA by epigenetic changes to do what it wants to do. And as you probably know, there's, I think, significant evidence now that stem cells don't work by growing new cells, but they work by exosomes.
Exactly.
And that's a long story, but nobody believed me when I said that 20 years ago. Anyway, yeah, so this is this communication system. Now, how do we bring that for the general public? Well, most people during COVID got a mRNA spike protein vaccine. And that mRNA was shot into our arm, and it told our cells to manufacture the spike protein of the COVID virus, which was a really dumb thing to do. But we won't go there. But our cells manufactured the spike protein because it was told to do that by messenger RNA.
That we injected into our cells.
That we injected into our cells. So now we know that a bacteria in our gut can actually send our brain, our heart, messenger RNA to make something that the bacteria wants us to make.
Wow.
And that's why it gets so deep.
Yeah. So, I mean, this is pretty incredible that bacteria are communicating with all of our cells, even the mitochondria inside of our cells.
Absolutely.
Through gas, through butyrate, and now also through micro messenger RNAs as well. And for the audience, messenger RNA is kind of like a different version of a DNA molecule. They're base pairs that can interact with our DNA and have us make different proteins and different communication molecules inside of our own cells. And so these messenger RNA, you say, can also travel to our brain and cause the same thing to happen there.
Yeah, that's exactly right.
Incredible.
We can actually, one of the things that was startling to me, a little bit off subject, but just how complex this system is.
Yeah, it's really crazy.
You, I know, probably look at coronary calcium scores.
All the time, yeah.
Okay. As I always tell my patients, a coronary calcium score and $5 will get you a cup of coffee at Starbucks. But we won't go there today.
Exactly.
So where the heck is that coronary calcium coming from? And there's been two competing theories. One is there are really only two tissues that are capable of producing bone, calcification. One of those are obviously osteoblasts, bone.
Our bones, right?
Right. The other thing that's possible is there are bacteria that make biofilms of igloos that are calcified.
Right.
And anyone who's been to the dentist and have their tooth cleaned know that they're scraping off calcium. So there's been a couple competing theories that calcification is actually from bacteria, oral bacteria, that have invaded the wall of the blood vessels and have set up shop. And their plaque, that calcium, is from bacteria. And I won't go down that road. And we could, but I won't.
Yeah.
The other newest competing theory is that if you have leaky gut, one of my favorite subjects, then macrophages, a type of white blood cell, are activated by lipopolysaccharides, which I affectionately call little pieces of shit, which is what they are.
Yeah.
These macrophages can go into the smooth muscle of our blood vessels
Right.
and via exosomes tell that smooth muscle cell to become a bone cell,
To become calcified.
become a bone-making cell.
Wow.
And you go, wait a minute, how can a smooth muscle cell become a bone
Yeah.
cell?
How does that happen? Right.
Well, everybody's genes, the gene of a smooth muscle cell, are identical to the gene of a bone cell. It's just what part of that gene expression has been activated. And who tells a smooth muscle cell to be a smooth muscle cell versus a bone-making cell? In these experiments, now these are animal experiments, you can have a macrophage tell a smooth muscle cell, stop being a smooth muscle cell, I want you to become a bone-making cell. Whoa.
Yeah.
All because of these little bits of information.
So these macrophages that are invading our vessel wall when we get plaque in it or cholesterol deposited in it actually are telling the smooth muscle that is normally present in our vessel wall to turn into a bone-making cell. And that's what's causing
That's where the calcium comes
calcification. Why would it do that? It's trying to stabilize the plaque is what, the theory is, right?
Well, actually, I picked up on this years ago. We use, among the other vessel health tests that we use a marker called ADMA. And ADMA is a pretty good way of looking at inflammation in the wall, but it actually looks at stiffness in the vessel wall. So if you and I had a cold, our ADMA would go up. If you had dental cleaning, your ADMA would go up for 2 to 3 weeks after dental cleaning. And you go, well, why getting my teeth clean would make my ADMA? And I would notice this. Well, we put 2 billion bacteria into our bloodstream every time we have our tooth cleaned. Now don't go out and not get your tooth cleaned. It's okay. But so I would recognize this because I do the blood work on my patients every 3 months. And I'd see that, dental work would do it. I saw that COVID shots did that. I saw it with COVID. And so I postulated that anytime we think there might be bacteria in our bloodstream, we stiffen up the walls of our blood vessels to try to keep them from getting through. Fences make good neighbors.
Yeah.
And anytime bacteria are where they shouldn't be, we try to put up fences.
Got it.
My supposition is that for most of us, we have, sadly, leaky gut 24 hours a day. So we're constantly being exposed to these signals that bacteria are getting into us. And so why not put up fences, the best there is, bone. Against these guys?
Makes sense. And that's the tie-in with the LPS through leaky gut, activating macrophages, making them think that we have bacteria floating around, and therefore we need to put up these fences.
Yeah. That's exactly right.
So is there research showing that people with leaky gut have more calcified blood vessels?
In experimental animals, yes.
Yes.
I would contend, at least with my patients now, absolutely that's true.
Right.
The thing that's been fascinating to me is that as a heart surgeon, I knew that these calcifications were not on the inside of the blood vessel. They were in the media and actually the adventitia. And they, from my standpoint, never correlated with plaque on the inside of the blood vessels. And that's to this day, insurance still doesn't pay for a coronary calcium scan.
Right. Right.
So, but it does, for me, tell my patients that, hey guys, there's something going on and we need to look why that's occurring. And I try to convince my patients that it's occurring because it's from below that all this started.
It's so incredible to me how much is being tied back into the gut, how much of chronic disease really just starts in the gut, right? And it's unfortunate, though, that the signals of leaky gut, for example, sometimes people have no idea they have leaky gut for decades and decades. They just live with it.
Absolutely.
Because the symptomatology is sometimes very lagging. And some people I find with severe leaky gut and they have no symptoms and they're so surprised. They have no idea this was even happening for decades, right? And so it's just really incredible to me how, it seems to me like what we need to be doing is screening for leaky gut in almost all of our patients because it is a problem and it is leading to all of this chronic disease.
Yeah, no, you're absolutely right. Hippocrates, the father of medicine,
he said
2,500 years ago said
told
all
us.
disease begins in the gut.
Right.
And, I've been spending 30 years trying to figure out how this guy knew this.
Yeah.
And I think a better way of framing it, particularly from a longevity standpoint, and that's what you and I are interested in,
Right.
is the other way to phrase that is that death begins in the gut.
Yeah.
And if that's true, and I certainly believe that's true, and the evidence certainly points to that if we want to extend health span, which is obviously what we want, not lifespan.
Right.
I have no interest sitting in the nursing home drooling in my oatmeal.
Exactly.
I don't think you do either. So if we want to extend health span, then that's where we need to look. And what's been interesting in the last few books is you look at these super agers. They carry a lot of interesting findings in their gut. They have a gut microbiome diversity. I mean, these are 95-year-olds, 100-year-olds, 105-year-olds. That's more like a 30-year-old.
Right.
And it's incredibly diverse. And the other thing is, which I think is really important for our modern age, is their gut microbiome actually loves to eat what are called xenoantigens, like PFAS, like all these toxins, like mold toxins. Interestingly enough, mold, fungi, and bacteria basically hate each other because they compete for the same resource, carbon atoms. And most of our antibiotics, as you and I know, were derived from fungal products.
For sure.
Toxins.
Yeah.
And to kill bacteria.
To kill bacteria, right.
And so bacteria hate fungi just as much. And these bacteria and these superagers are really good at detoxifying mold toxins.
Oh, so interesting.
Unfortunately, most of us don't have those guys.
Yeah.
So when we look at these superagers, no wonder they're superagers because all of these guys, and I study them. I'll show you a picture of a 100-year-old guy who's just unbelievable. His gut wall's intact. He's got this incredible set of flora. Now, did he do anything unique? No, he didn't. But and that, I think, is beside the point, where it actually is the point. These sheep herders in Sardinia, they're not getting infusions in your lab.
Nope.
And they're doing pretty doggone good.
Pretty good, right.
But what they've done is they've just got this incredible gut flora, and the wall of their gut is sealed.
Yeah. It's a super strong fence. And so, the way I talk to my patients about their gut and leaky gut is your gut basically has 3 layers of protection. It's the mucus layer, it's the bacteria, viruses, fungi that are diverse, that are living there, providing another layer. And that last layer is your enterocytes or your cells. But by the time you have leaky gut, your mucin layer has pretty much been decimated, your gut bacteria are not helping you anymore, and then your gut cells start separating from each other. And that's what causes the leaky gut, which then causes LPS, the little pieces of shit to come through, causes the antigens to come through from the food that you're eating, all the toxins come through, and that's the beginning of all disease. And you have to kind of have a strategy to keeping your gut healthy for the long term and keeping it healthy all the time, right? And so that strategy is what I've learned a lot from you in your books. And some of it's not as intuitive as you would think, right? I mean,
Right.
we were downstairs talking about vitamin D, for example, right? We know vitamin D is a critical nutrient for many biological processes, but who knew? I learned from you that vitamin D is critical for our gut bacteria.
Yeah. One of the things that when the plant paradox, actually before the plant paradox came out, my first book, Dr. Gundry's Diet Evolution, I talked about 2 patients who had autoimmune diseases that resolved. One of them with fibromyalgia and another one with Crohn's. And after that book came out in the early 2000s, people came to my clinic in Palm Springs and said, hey, I've got this autoimmune disease, and you talked about, what do you know about autoimmune disease? And I go, well, I don't know anything about autoimmune disease, but I'm a transplant immunologist. I ran a transplant immunology clinic, lab at Loma Linda, and I know a whole lot about the immune system and how to fool it. So if you want to play, let's play. But you ought to know, I don't know anything about autoimmune disease. And that's actually how we started. So now 80% of my practice is people with autoimmune disease who have been everywhere to, all the best clinics, and they're not getting any better. And it's because nobody was looking in their gut. So getting back to your question, all these people with autoimmune disease, when I first see them, one of their universal findings was that they had a low vitamin D level. And I go, that's interesting. So what's with that? So can I tell a story of how I learned about vitamin D?
I would love to, you two. Yeah,
So
please.
I think you and I both agree that we keep seeing patients because we learn from our patients. We're not.
It's critical. I'll never stop seeing patients because that's where I learn the most every day.
Yeah.
Right.
I'm 75 and I just signed a 10-year lease for my office in Montecito.
I know you did.
So
That's amazing.
I can't retire until I'm 85, and my wife said, not then even. So about 20 years ago, I was in my office in Palm Springs, and 2 new patients are sitting across from me, and they're in their late 70s. And I'm looking at their blood work, and both of them had vitamin D levels of 278 nanograms per milliliter. Now, you and I were taught that probably 80 was toxic, right?
The upper limit of what you want anyone. Yeah,
and
exactly.
certainly anything above.
But it's so funny because, you're taught that in medical school and you just don't even question it. You're like, someone must have looked at it and gave us 80 and, they must have done some study on this. Turns out there was never any studies done on what the toxic level of vitamin D is.
Yeah, and actually most of the studies on B vitamins, for instance, and vitamins in general, were done on 20 college students in New York City back in the 1930s.
It's crazy.
And they measured the levels and said, oh, well, these are the ranges of those levels, and they're healthy 20-year-olds, and those are the levels.
Yeah, that's what we should aim for.
No.
Crazy.
So here are these guys, incredibly high vitamin D levels. So you were taught that, it could raise calcium levels, it could cause kidney stones, it could damage kidneys, and there's even some suggestion that you could get numb fingers and numb toes if it was really high. So I'm going, and I'm looking at this, and they're all normal. And I'm going, any kidney stone? No. Any numb fingers and toes? No. And they said, why are you asking all these questions? And I said, well, you must take an awful lot of vitamin D. And they said, oh, yeah, it's a longevity hormone. And, I'm looking at them, I'm like, yeah, right. And he said, well, so what's the problem? And I said, well, from what I've been taught, you ought to be dead, And he leans towards me and he says, you don't know much about vitamin D, do you, Sonny?
Wow.
And I go, well, just what I've been taught.
Right.
And he said, well, why don't you read about it? And, of course, I did.
Yeah.
And, Michael Hollick from Boston University, et cetera. And I realized, holy cow, these guys were right. And then I started looking at vitamin D as a stem cell activator in the gut. And lo and behold, the gut wall is a very dynamic wall. We're shedding these guys. They're damaged all the time. And there's only one cell thick.
And doesn't that cell layer replicate itself or completely replace itself every 20 days or something
very
like
quickly.
that? Very quickly.
Yeah, even every 3 days, the turnover is that fast.
So those are the most active stem cells almost in our entire body.
That's exactly right. And so, lo and behold, I fall on a paper that says the stem cells in the gut are activated by vitamin D. And if you don't have much vitamin D, they just sit there and they don't activate. They don't plug the gaps.
Right.
And I'm going, wow, here's all these people with autoimmune disease. They have really low vitamin Ds. And now I know about vitamin D, so I'm going to push vitamin D on my patients. Now, this is before the days that we could measure leaky gut, before Dr. Fasano taught us, how this happened.
Right.
And what I realized was I would push their vitamin D until I got it somewhere between 100 and 150. Some folks we'd push higher, but 100 and 150. And for people who think that's high, both Quest and Cleveland Clinic say that 150 up to 150 is perfectly normal. And let's not panic.
No.
Anyhow, so I found that, like some people, I would have to give 40,000 international units a day of vitamin D3 plus K2 to start budging their vitamin Ds.
Yeah.
And as their vitamin Ds went up and up, two things happened. Number one, their autoimmune markers started going down. I mean, you could watch the two. And number two, eventually we'd reach a point where all of a sudden their vitamin D levels jump sky high. And then I said, oh, great, now we can start coming down. How come? Well, because now their gut wall was sealed and they could absorb vitamin D normally.
Got it, yeah.
And for many years until the leaky gut test came out, that's how I followed my dosing with vitamin D. And that's how I would know indirectly that the gut wall was being sealed.
I see. So when you see that jump in level, there's a sealing happening.
Yeah.
The gut's sealed, and now we can kind of back off a little bit.
Right.
Yeah. I have a patient. Well, no, you have a patient who's a really good friend of mine, one of our best friends, and you saw her about 10 years ago after she had a baby, and she had severe, severe rheumatoid arthritis. And she saw every rheumatologist in LA, and she was at her wit's end. And she credits you for saving her life because you changed her diet, you put her on vitamin D, and her rheumatoid completely cleared, like gone, like no autoimmune medications needed, and she was on the max dose of everything. Yeah. So once her gut was repaired, it completely reversed her postpartum rheumatoid symptoms completely. And she was having not just the joint aches, but also like brain fog it was horrible.
And she she didn't want to stay on immunosuppressants because she wanted to have another child.
Yeah.
And that was a big motivating factor is she wanted another child.
Right.
And she was smart enough to realize probably not a good idea to have a baby on immunosuppressants.
Right.
Probably. And one of the worries we had, one of the nice thing about pregnancies is that most people during pregnancy, their autoimmune goes into remission, whichever one that is, and for a good reason.
Yeah.
But when the pregnancy ends, usually it
Massive flare.
blows up like, in spades.
Yeah.
And she was one of my earlier ones. She did not explode after her second pregnancy. She didn't flare.
No, she didn't.
And I go, now we're on to something here.
Yeah.
So,
So you remember who I'm talking
oh,
about. She credits you for, basically saving her life. And her second pregnancy went great and no problems. And it's such an incredible story. And I just feel so bad for the people that don't know this information, because there are thousands and thousands of people clamoring into rheumatologist's office right now. And there's no mention of leaky gut. Let's take a look at your gut made at all. So hopefully, if anyone's listening to this podcast and they can, learn from this, because it can completely change your life. And there's no downside to doing this. Right?
yeah.
There's no downside taking some extra vitamin D and, changing your diet to where we can get your gut healed.
Yeah, I mean, there's even evidence that people who live the longest have the highest levels of vitamin D.
Right.
And it's like this guy was trying to tell me 20 years ago.
Yeah.
I'm going, it's a longevity hormone? Are you sure? Well, yeah, it is for so many reasons.
Yeah. Can we talk about, since we're on the topic, you've learned a lot over your last 10 books now about how to heal the gut. Besides vitamin D, can you maybe give the listeners like 4 or 5 other key ingredients that you feel, if you have a leaky gut, this will heal it?
Sure. Let me preface that with saying every now and then I come on a podcast where everybody is armed to the teeth with, how dare you talk about lectins, that there are a lot of people around the world that eat lectins and they're perfectly fine. And, they're eating tomatoes and they're eating beans and they're fine. And how dare you? And one of the things that was missed in the plant paradox is, lectins are part of the plant defense system against being eaten. Oxalates are another part. Phytates are another part. And they don't want to be eaten by animals. Animals don't want to be bothered by these plant offensive weapons.
Sure.
And so animals evolved a very strong microbiome defense system that likes to eat these things. There are microbiomes that like to eat gluten. Most of us don't have those guys anymore.
Nope.
There are microbiomes that love oxalates.
Right.
And people who have oxalate kidney stones, people who feel oxalates, you can look, they don't have any oxalobacteria. They're gone. So that defense system, well, let's call them the offensive line of a football team.
Sure.
They're there to protect the quarterback from these linebackers from sacking them.
Yes.
Well, that defense system is gone in most of us because of antibiotics, because of PPIs, because of glyphosate. They're gone. And now we got the third stringers in, and they're carrying some water boy out to try and protect the quarterback, us, the wall of our gut.
Right.
And it's no wonder it's being sacked constantly.
Yeah.
And people forget that. I can eat some lectins and do okay, although we could tell a funny story. But we forget that we got to have those guys as our initial line of defense.
Right.
And we've got to have mucus-producing bacteria or mucus-inciting bacteria as our second line of defense.
Right.
And then, like I tell my patients, I can seal the wall of your gut. It'll take us a while. It'll take us 9 months to a year, probably, maybe worse. But if you keep swallowing razor blades, you'll just tear it right open.
Right.
And for many of us, oxalates, lectins are razor blades.
Phytates, yep.
There's certain razor blades that are more important for some people than other people. And the good news is we can test for food sensitivities, which razor blades are bad, for me, not necessarily you. So it's all of, we gotta get our offensive front four repaired.
Yeah. And then you can go back to it in the future once you're fully healed.
Well, that's exactly right.
Yeah, exactly.
Most of the time, most people can actually reintroduce a lot of these foods.
Right.
Sometimes there's certain foods that never can we reintroduce them, unfortunately.
Right. And I found that, real life with so many patients that, not everyone needs to have lectins removed from their diet, but it definitely gives your gut less to have to defend against while you're trying to heal the gut, right? Same with gluten, right? If you can eliminate these foods for the time that you're trying to heal the gut, get your gut healed, and then slowly reintroduce and see if you can tolerate them, that's fine, right? But at the beginning, during the healing protocol, I think eliminating certain foods, such as lectin-containing foods, gluten-containing foods, can dramatically accelerate the repair process.
Yeah, 100% of my patients with autoimmune disease, number one, have leaky gut.
Right.
100%.
100%.
100%.
Yeah.
Haven't
Makes
seen
sense.
one yet.
Makes total sense.
100% of those people have antibodies to the various forms of gluten. 100% of them.
Yeah. Makes sense.
70% of them have antibodies to corn. And so, at least, if you have an autoimmune disease, then just, for goodness sakes, get that out of your diet.
Right.
And the longer I do this, the more I'm impressed that glyphosate Roundup is a big contributing factor in not only making gluten more mischievous, but in producing leaky gut and in actually affecting mitochondrial function. So but that's another day.
Yeah. No, we test our patients for glyphosate buildup actually with a urine test. And it's incredible. I would say about 50-60% of people have toxic levels of glyphosate. It's mind-blowing how much is still in our environment.
And it goes up every year.
Yeah, it's really a big problem. And so, I think you have to have an active practice of avoiding pesticides with your food. And there's a lot we can talk about there, obviously, but that's definitely contributing to massive amounts of leaky gut right now.
Yeah.
Okay, so we talked about eliminating certain foods. We talked about vitamin D. A couple of other things you might have for us?
Yeah, so I think, and I've talked about this in the last two books, and I got to give a shout out. There's a husband and wife microbiology team at Stanford, the Sonnenbergs. And the Sonnenbergs are kind of the doomsayers of the microbiome. And they think we have a desert wasteland for a microbiome, and they are correct. And they think we will never, ever improve on our desert wasteland. They do not think that we can rebuild a tropical rainforest, probably because of the environment we live in.
Yeah.
And they're probably right, but one of the things that they did, which was so important, so we know that most of the good bacteria like to eat soluble fiber, and soluble fiber is fiber that dissolves in water.
Right.
Insoluble fiber doesn't dissolve in water.
Yeah.
And most of the things that our bacteria like to eat is soluble fiber. So they said, hey, let's take some volunteers. Let's measure some markers of inflammation. Let's look at C-reactive protein. Let's look at gut microbiome diversity. And let's give them a nice, generous helping of a really good soluble fiber called inulin.
Yeah.
So inulin's in chicory, it's in artichokes, it's in asparagus. And let's look at what happens.
Sure.
Well, the microbiome didn't change. Their inflammatory markers didn't change. And I go, well, what the heck? So much for that. And then to their credit, they said, well, wait a minute. Maybe there's something else that needs to be introduced into the mix. And fermented foods have, number one, a lot of bacteria.
Yeah.
But they also have the products of bacterial fermentation, which we now call postbiotics.
Postbiotics, right.
Let's do the experiment again, but give them the inulin, but we'll also give them fermented foods. Now, in this experiment, it was mostly yogurts and kefirs. Lo and behold, the combination of the two, much better diversity of the gut microbiome, and the inflammatory markers went down. So, again, you've got to have another building block to add to the equation.
Got it.
And one of the ways to look at this is we're beginning to realize that each of these bacteria has a role, and it's almost like a car assembly line. Let's suppose that we want to make butyrate, which is the holy grail of short-chain fatty acids. Good stuff.
Yeah.
We need probably 5 different bacteria, each of them eating something that each bacteria ate to end up with the final product.
Yeah.
And if one of those guys is missing or the thing it's eating missing, you don't get the car. And that's where I think personalized medicine is going to go eventually is we're going to know who those guys are. We're going to figure out what they want to eat, how to grow them. A lot of these bacteria we can identify, but we can't produce them commercially yet. It's like it took 10 years to do Akkermansia.
Yeah. I had Colleen on here, and the story is crazy. How long it took to make Akkermansia?
Yeah,
it's a very, very in-depth process requiring very strict manufacturing. But the reality is, like, if we can repopulate our gut with Akkermansia and treat it well with what it needs to eat, we don't have to. We don't have to grow it anymore, But we just can't do that anymore. It feels like your friends might be right. Like, it just seems it's so hard to get our gut bacteria to be diverse again.
No, it really is.
Yeah.
And one of the things Dale Bredesen, who wrote The End of Alzheimer's, who I personally think is the smartest neurologist in dementia there is, but he's a friend. One of the things, he and I are both interested in the ApoE4 mutation, which is, quote, the Alzheimer's gene. I got interested in it as a heart surgeon because it's a really devastating problem with developing coronary artery disease. So when I wrote in Gut Check, it turns out that dumb gene doesn't like butyrate-producing bacteria to live in the gut.
Oh, no.
And it actively produces bacterial proteins that keep those guys suppressed. And so, lo and behold, so there's another piece of the puzzle why is this gene so mischievous? It's because you can't grow the keystone species because your gene doesn't like it. So all my patients with ApoE4, I have them take butyrate-producing bacteria basically as a daily multivitamin. Because your gene is going to try to kill them, but you got to keep stuffing them in there. And so far, it's working.
That's such an another useful piece of information, incredibly useful. What is the bacteria that you're giving them?
So we're giving them actually Akkermansia and several of the Clostridium species that make butyrate.
Oh, wow. So interesting. We're doing a study here at Next Health right now. A friend of mine, he's also a GI surgeon, recognized that bacteria in the gut, in different places in the gut, require different food and different types of fiber, right? Yeah. So he's putting together a fiber blend, and we're going to be testing pre and post stool test to see how does a special fiber blend, to your point of personalized medicine. How do we personalize the fiber intake to what the bacteria need to further diversify the microbiome? So, a lot of the fiber you buy right now is just one type of fiber, and there's many different types of fibers out there. So we're doing a study on this right now.
Yeah, and if you think about, if you look at hunter-gatherers, they're acquiring different fibers, not only on a daily basis, but on a seasonal basis. And maybe we should be varying on a circadian basis the types of fibers that we're ingesting. And maybe, because we know that their microbiome changes dramatically with the seasons, depending on what they eat. And maybe that circadian change is actually incredibly beneficial.
Right.
We just developed our newest product is called Active-Biome from Gundry MD. And what we did was, again, we know there's an assembly line to make butyrate, and we know Akkermansia is really important. So what we've done is we've got the strongest form of acetate that doesn't break down. Acetic acid is another short-chain fatty acid that you got to have to make butyrate.
Right.
And apple cider vinegar works because it's a postbiotic, short-chain fatty acid.
I got it.
So we've combined Akkermansia with several other of the precursors, and so far so good.
What's the name of that product?
It's called
again?
Akkermansia.
Active
Brand
Biome.
new. It's the first. It's
I got to get me some of that.
we'll get you some. We'll get you some.
I love it. It's just so incredible what we're learning. And just, it's a simple solution to have such an outsized effect. We've talked a lot about autoimmune disease, but also this is related to attention deficit disorder, depression, schizophrenia even. There's so many tie-ins with gut health to mental health as well.
Yeah, and this book, spends a lot of time in terms of mental health, in terms of, anger management.
Right.
And one of the things that was surprising was, we've been told that antidepressants like SSRIs, serotonin reuptake inhibitors, work by, keeping more serotonin in the brain. Yeah. Well, number one, we now realize that the serotonin is being made in the gut, and it's actually being made by gut bacteria. But one of the odd things, anybody who's treated people with depression with SSRIs, if you and I took an SSRI and it worked the way it was supposed to work, then you and I tomorrow would be waking up giddy, laughing, and just thinking it's the most beautiful day in the world. Right. Because we'd be flooded with serotonin in our brain.
Right.
That's not it doesn't work like that. It takes a month or more if you're even going to see an effect. So then people said, well, wait a minute. What's going on? Maybe we should look at the microbiome. And it turns out that these SSRIs change the microbiome to be more of a serotonin-producing microbiome. So it wasn't happening up here. They were happening down here. And that was one of the first keys that, oh my gosh, we're looking in the wrong place for what's going on up here.
Wow.
Yeah.
So we developed this drug called an SSRI, thinking we knew what the mechanism was and how it was working.
How smart we are.
Yeah, exactly. But it's actually doing it completely differently.
Completely differently.
By working in the gut. Yeah. Mind-blowing. So are there certain bacterial strains that help us produce more serotonin in the gut?
Yeah, there are. The problem is that one of the sad things we've learned about Roundup and glyphosate is that glyphosate was actually developed as an antibiotic. It was patented as an antibiotic by Monsanto. It wasn't patented as a weed killer.
Oh, okay.
So it works on the shikimate pathway, and bacteria actually use the shikimate pathway to reproduce. We don't, and so Monsanto convinced the FDA, hey, it's perfectly fine. You can swallow a gallon of glyphosate and you'll be fine. What we didn't know is that glyphosate particularly targets the tryptophan pathway bacteria that make serotonin. So people who are exposed to glyphosate, they're the good guys that make tryptophan, that make serotonin, have been wiped out. And it's no wonder that we have an epidemic of depression and anxiety. Now, granted, we can blame cell phones and COVID and all that, and that has a place.
Yeah.
But to target the actual bacteria that are responsible for making serotonin. Yeah. So
it's so incredible to me, these hidden dangers of these chemicals that you don't even know. And we always trust our government to say or tell us that what they're putting out there is going to be fine for us. But the reality is they don't. I mean, these manufacturers are allowed to dump these chemicals into our environment without any testing until we find out years and years later the damage that it can do.
Yeah, I mean, there's a fascinating herbicide that is banned by the EPA in the United States, but it's used on oats because oat stalks grow very high, and oats are very heavy. Right. And they grow so high that the wind breaks the stalk, and it's, number one, it doesn't grow, but it's hard to harvest. So there is this herbicide that if you spray it on oats, it shortens the growth of the stalk so it doesn't break, and it's easier to harvest. It's banned in all countries. The EPA bans it but it allows a certain level to be detectable in oats in the United States. And during the first Trump administration, the EPA was instructed to double the level of the banned substance that it would tolerate. And so now all of our oats in the United States test positive for a banned substance. And this particular substance is really good at causing reproductive abnormalities and nerve system abnormalities.
Oh my gosh.
And it's not allowed, but it's allowed.
Yeah, it's not allowed, but allowed. Yeah, I've never been a big fan of oats. It's just really hard to justify. That's another reason.
It's another reason.
Another reason. And then,
even all the organic oats could test positive for glyphosate.
Oh, yeah.
It's like, well, wait a minute, how could that be? Right?
Absolutely, yeah. And also, you see people that eat oats in the morning, their sugar regulation for the rest of the day is completely thrown off, and they have much higher rates of developing diabetes and metabolic disease. So one of the other concepts, I wrote down a note here in your book, is the concept of the holobiome. Can we talk about that? What is that and why is that important? Why should people know about the holobiome?
Well, the holobiome is a much better term than the microbiome. The microbiome is from basically in our gut, and let's include the oral cavity as the microbiome. But we have a microbiome in our skin. There's over 700 species of skin bacteria. We have a microbiome in our nasal cavities. We have a microbiome in any gland that reaches the outside. So breast tissue has a microbiome, our prostate has a microbiome, the uterus has a microbiome, the placenta has a microbiome.
Oh, okay.
And there is a microbiome cloud around you and me. Who was the character in Peanuts who had that?
Was it Linus maybe?
It was another kid anyway. So, and there's kind of a cool theory that the reason there is a personal space that we maintain that feels uncomfortable when someone gets closer is that your microbiome starts to impinge on my microbiome or holobiome.
Right.
And there's even, for instance, kissing is a universal human trait, and it's also present in a great number of animals. Yeah. And there's a cool theory that your microbiome, your holobiome, is checking out your potential mate's holobiome to see if they're compatible. And maybe even to see if your, for instance, her vaginal microbiome is interested in your semen microbiome because there is a lot of anti-spermicidal compounds, and a lot of times some of these infertile men and women couples, the woman is producing spermicidal compounds, and maybe we should do some kissing tests with these folks and find out if their holobiome is compatible. Can you imagine getting your marriage license by getting a oral microbiome test for both of you and see if they're compatible?
See if they're compatible. I mean, there are people now. I mean, there's a lot of talk in dentistry as well of
absolutely.
The oral microbiome now, right? And
yeah, absolutely. Because and Dale Bredesen is a big proponent of this. I'm a big proponent from a cardiovascular standpoint. We don't want these certain bacteria to get into our bloodstream. And if you think about it, the upper dental arch, I mean, it's an inch from your brain.
Right.
And it's literally a straight shot. And neuroinflammation is, rampant. Now, both Bredesen and I agree that neuroinflammation begins in the gut for most of us, but let's call the oral microbiome the gut as well and go after that.
Right. I mean, and just we've known for years that for some reason people with poor dental health have a higher rate of neurodegenerative disease.
Yeah,
and
absolutely.
This is the reason why.
Yeah.
This is absolutely the reason why.
How could that be? They just don't take care of themselves, or it's because of this.
It's all microbiome related.
It is. Hippocrates is right. I'm sorry. We have to get over it. The guy was a genius.
Yeah, absolutely, absolute genius. He just didn't even have a microscope. Did
No,
he didn't have a
he
microscope.
didn't have any of this.
Exactly.
It's funny. I've got a Buddhist scholar as one of my patients, and he reads Sanskrit perfectly. And we were talking about this one day, and he said, the Buddha always talks about enlightenment. And if you don't mind, I'm just going to read some of those texts, and I'll get back to you. So he calls me up. He says, you're not going to believe this. The Buddha said enlightenment comes from the intestines. Now, the Buddha and Hippocrates were contemporaries, but they obviously
Never
didn't
knew each
interact.
other, right?
But here's the Eastern philosophy going, what the heck? Enlightenment comes from the intestines? Yeah. Wow. How did he know that? And I'm just writing about it. I'm a slow learner, I guess.
Well, we all have a lot to learn from you. And so I'm so excited that you wrote this book, The Gut-Brain Paradox. I can't wait to order it, read it. When does it go on sale?
Well, it's actually on. It's out.
It's out now.
It came out in April of this year.
Fantastic.
Actually, a couple weeks ago, went to number 2 on Amazon when I went on the Morning Joe podcast show on MSNBC.
I love it.
So it's around.
Okay, great. Well,
it'll be in the
hopefully you'll
bookstores.
let me have this copy that's sitting
I'll
right
let you
here.
have that one.
I can't wait. And it just looks like it's supported like 300 pages, 200 pages?
Yeah, about that.
Yeah.
And half of it's references.
I mean, I think
if you've read any of my books,
Yeah,
they're
there's a lot of
heavily referenced.
Right.
I don't make this stuff up.
Yeah, no, it's all very scientifically based. Yeah, and what an incredible book to read to really reframe how important the gut is to our overall health. And I think everyone needs to know this. Everyone needs this information. And so I really appreciate you putting it in paper for all of us. And thank you so much for being on our podcast.
Well, thanks for having me. It's great to see you again.
And if you don't know how to find Dr. Gundry, that's a big problem because Dr. Gundry's everywhere. But just in case, can you tell everyone where to find you?
So you can go to my podcast, the
Yes.
Dr. Gundry podcast, wherever you get your podcasts. GundryMD.com is my supplement food company, drgundry.com. 2 YouTube channels. We've got over a million subscribers, I'm happy to say. So, and hopefully every day on your feeds, I'm waving at you, asking you to come and visit me.
I love it. Thank you so much. And it's an absolute pleasure having you. And I can't wait to have you on again for your next book.
All right.
Thank
And
you.
I can't tell you the title yet, or I'd have to kill me.
No, we got to keep you alive for sure. All right. Thank you.